Next, we're going to talk about some of the large team integration in science. So, whenever you're dealing with large groups, you've got to have a simple implementation. You might have a tremendous amount of precision by doing everything on an individual basis, but that is going to lead to an inability to implement it. If you've got 40 or 60 people on the floor at one time doing different velocities, you can't do that because you are not going to be able to keep track of it, and most of the time the athletes aren't going to be able to remember their own velocity anyways. What I've noticed is that about 5 to 10 people on a team, in a group, seems to be about the limit of what I could handle whenever I was dealing with individual velocities. So, I like the zones for the simple implementation, and I lose some precision with that, and I'm okay with it. The feedback is one of the key areas that's going to aid in the coaching, and it's going to aid in the intent of moving the bar fast. And it also is going to encourage competitiveness, which we'll get to here in a minute. Now, one of the things that I want to do and show you is like, hey, why would we want to use this? Well, I'm getting ready to show you a American football team over a 4-year period of development. So we've got 2 different 4-year periods, right? So the first 4-year period is whenever they just did the traditional percentage-based training. And then the second, what is listed as levels, is utilizing VBT. Now, we did the Sayers equation on the counter movement jump to give us peak anaerobic power in watts, and then we broke it down by a percentage change. And then the x-axis is the year, okay? And the percentage of change as it related back to the initial testing session. So basically what we see here is that where with the traditional system they went up for a year, well, we went up for 2. And we did have a plateau. Now, some people might look at this and be like, well, this is just not accurate because this is just your program, and obviously with the traditional training you didn't do it right. Well, guess what? Same stuff was found by Texas A&M, Oklahoma State, and University of Dayton that were published articles. Now, why was ours different? Well, we used VBT zones with our level, and they led to a greater power outputs than traditional training. Now, was it from the intent? Was it from something else? I don't know. Was it because of the load? Who knows? But I do know that the VBT zones led to power increases for a greater number of years. And then the VBT is definitely effective in a large team setting. We see that. Now, that year 3 to year 4, we saw that we had a plateau. Now, there are some thoughts behind this, and you're never really going to notice what's going on whenever you're in the thick of it. It's not until you're able to step back and get that 30,000 foot view. So I didn't do this until after we were done with our time at Missouri. But year 3 and 4, well, obviously it plateaued. Well, what could have caused it to increase? Well, for one, the only thing that we ever did was strength speed on squats. We didn't ever go to a faster velocity like a speed strength and use high band resistance and low bar weight to try and look for greater times in acceleration, etc. So if we would have looked over to speed strength, I think that might have helped. And also if we would have gone from the clean as the Olympic lift movement that we were performing to something faster like the snatch, that might have stimulated greater velocity adaptations if we look back to the work from Kaneko et al. To where we're getting better velocity and lower force improvements because their force was already good. It's also possible that we needed to completely change the methods altogether. Maybe we needed to look at specificity of exercise because everything that we did were general movements, general exercises. If we would have looked at the specific ones, maybe that would have made a difference. I don't know, and we'll never truly know because I don't think that we'll have that amount of time in one location working with a football team again. Now, how does VBT help? Well, of course, there's the SAID principle, the specific adaptations to impose demands principle. Now, whenever we used, and I need to go ahead and point out that there's a flaw with these. Now, this data, these zones that I'm showing you right now, these were created off of Division I athletes. And while we did utilize multiple sports within them, we have to realize that the Division I athlete is very, very homogeneous. So we took it based off of the averages of what they did, and it was about plus or minus 0.05%, and we related that back to the percentages of 1RM. So absolute strength, which is 80% plus, came out to be about 0.5 meters per second and on up, and on slower than our accelerative strength, which was the ability to accelerate through a load. That was from 0.5 to 0.75 meters per second, so or about 55-60% up to around 80. Then we have strength speed and speed strength, and we've got this 30 to 70% of 1RM that's just kind of overlapping. Now, the strength speed is 0.75 to 1.0, and speed strength tends to be about 1.0 to 1.3. And the strength speed, we're looking more up around that 60% zone. Now, what is unique about that is that you will see through training at 60% of 1RM equal improvements in force and velocity, as found by Kaneko et al. In 1984 paper. With the speed strength, we're training more down to the 30% of 1RM, where they saw tremendous improvements in velocity and smaller improvements in force, but it led to a great improvement in power. And then we're looking at starting strength. And starting strength is the ability to rapidly overcome inertia. And calling it strength is a bit of a fallacy. It might be a translational issue where maybe we should call it starting speed. But it's just rapidly overcoming inertia, going from the first step and how fast can you get going and move. Now, also, I need to point out that these are for the big rock exercises only. There's a lot of people out there who are trying to do VBT on a multitude of different exercises, and I don't think that it really is an efficacious use of time or training. But with these big rock exercises, while the terminal velocities might be different, like for the bench press, and honestly, I include the bench press within these velocity zones, even though it doesn't truly meet them. And the reason why I do that is because the bench press typically doesn't make a tremendously great impact in sport, because you don't walk out on the field on your hands. So to keep things simple for the athletes and for the coaches, I just left it the same. Now, if we look here, we see you could take you can tweet this out now. This has actually already come out. If we look here, we see the speed of the bench press, and on the dotted line, we look at the speed of the trap bar deadlift. And we can see that, hey, everything fits pretty tightly around a line. Yeah, we've got a couple of outliers here at this 80%, but they stay roughly, their own individual line, just a little bit lower. But the point being here is that they're very linear relationship, and the slope is very, very close to the same. During the movements that we would be performing, these lines don't intersect. Now, with VBT, it's pretty tough to differentiate those traits if you don't utilize velocity. And one of the reasons why is because you can move a lightweight slow, or you can move a lightweight fast. Now, with the speed strength, most Olympic lifts by nature are speed strength, but they aren't always, because you can perform them incorrectly. Now, one of the things that I often talk about is the utilization of Olympic lifts and how we came to use velocity at University of Missouri. I had to do a stats class. I had to do a mini thesis as a part of a statistics class. Basically, it's a 25-page paper on something that you cared about. Well, I decided that I was going to do one on how the Olympic lifts were, improvement in the Olympic lifts were related to improvements in vertical jump. Because I just knew that's why we did it. We do cleans, the Olympic lifts, to improve explosive power, and we measure changes in power from the vertical jump. Well, whenever we ran the data, we saw that there was no relationship between the two. And we had to step back and think. It's like, hey, what just happened here? Why is this going on? And we realized, upon stepping back and looking at it, that our Olympic lifts had become just for weight. How much weight could somebody get up? And they weren't done for speed. So whenever we added a threshold velocity in, all of a sudden they started improving in their ability to produce power. Now, the clean was never the biggest one for us for improvements in power. It was always improvement in body composition. Of course, if you have muscle mass versus fat mass, you're going to be able to be more powerful. And the other was with the younger teams, at least, improvements in squat strength. And I think that we know that from the work from Sukamel, Nymphius, and Stone, that up to about a double, 2.25 times body weight squat, there are improvements in speed and power. And after that strength level, increasing strength did not seem to increase into speed and power. It might lead to adaptations that would allow power to improve from other exercise means, but it did not in and of itself translate to improvements in speed and power. So with those weaker athletes, again, getting them up to the double body weight squat was our number one trainable factor for improving speed and power. Now, with them, you will see in the literature there's strength, speed, speed, strength. Jindaka called them load velocity and velocity load. As I just mentioned earlier, strength speed is about 60%. You're getting with a little bit heavier weight, a little bit slower acceleration, slower RFD, 0.75 to 1.0. With speed strength, you're typically looking at 1 to 1.3. And again, we're looking at around 60% for strength speed, 30% for speed strength of 1 RM.